Okay, so let us discuss about the relation between potential energy and conservative force. Okay, so first of all, we should know that suppose if there is a conservative force, it is defined as minus du by dx. Okay, conservative force, one dimension, is defined like this. Otherwise, in three dimensions, it is defined as a partial differentiation. In three dimensions, as a vector form, conservative force is given as minus dou by dou x of u minus and I cap, of course, I cap minus dou by dou y of u j cap minus dou by dou z of u j cap. Or in short, we can write this as minus del vector of u. Okay. So in short, it is written like this. Okay. Right. And this is also called gradient. This del vector of u is called grad 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 u grad u. Grad is a mathematical operation. Grad means it is del vector. Okay. But anyway, that is not important. That is maths. Okay. So let us take a simple case, one dimension. The conservative force and potential energy are related like this. Okay, conservative force and potential energy. Now, suppose if I have a graph of potential energy and x, and let us say the graph is like this. Okay, this is the graph. Note the nature of this graph. Try to understand this graph. This side from here to here completely concave is there. Okay, at one point its nature is changing, it is becoming convex. Okay, so nature of the graph you understand first. So this side up to this side it is concave and then it is becoming convex. So there is a point where it is changing the shape of the graph, it is changing. This is a point where graph shape is changing, and this is a point where there is a minima. You understand, right? Minima means slope is 0. Okay, slope is 0. So this is a point where the slope du by dx is 0. So if slope is 0 here, then force will be 0 because du by dx becomes 0. Now I want to draw the graph of force. Okay, let us try to draw the force graph. Force versus x graph. Force means the same conservative force. So we already know at this point where the potential energy is minimum, at this point force has to be 0, that we know. And this point is the graph shape is changing. Shape of the graph changing, what does that mean at this point? Shape of the graph changes, what does that mean? Let us try to understand that. So if we know that the force, conservative force is given as minus du by dx, and suppose if I differentiate this, that means I differentiate force with respect to x. Then this minus is there, and differentiation of this become double differentiation d square u by dx square. Okay. So if you differentiate force, you will get minus double differentiation of potential energy. Okay. So I want to draw the force graph. So first of all, you should see here this slope. Slope of this is negative up to this much. Note that slope of this graph up to this much. Slope of this graph is negative, right? This graph slope is negative up to this much. So if slope is negative, if slope becomes negative, negative become positive. So force will be positive. Right? So that means if I draw the force graph is positive like this. This way it is positive. Okay. Force graph is positive from this point onwards. From this point left side, force graph is positive. And force is 0 here because this is the minimum. So force has become 0. After that, this slope is positive. So when slope is positive, force is going to be negative because negative into positive is negative. So After this point, graph is below this, right? Force graph is below x-axis, so negative will be there. But now let us understand this shape of the graph. So here if you see this slope of the force graph is minus double differentiation, and double differentiation of potential is coming as the shape of the potential graph. Okay, so you know double differentiation is positive means concave, double differentiation negative means convex, right? So if you look at this graph, this graph from here to here, this graph from here to here, it's a concave graph, concave graph. So if concave graph is there, it is positive, so this will become negative. Okay, so the slope of this graph is going to be negative. Okay, so negative slope will happen for where? For up to this much, this concave. So negative slope means let us extend this graph further in the same manner and keep it like this. Okay, uh, this is like this. Okay, I have extended, slope is negative. Now here this is a convex graph. Convex means double differentiation negative, negative negative will become positive. So after this point it has to be positive, that means this has to go, slope has to be positive, so slope is going to change here like this. Okay, so this is the point where the force is getting a minima. Force is having a minima at that point, because this force differentiation will be zero when double differentiation is zero. When is double differentiation zero? Double differentiation is zero when this graph is changing its sign, because before it is concave, after that is convex. So this is the point where d square u by dx square is equal to 0. Are you understanding this? Right? That is why at this point, the slope of force graph is 0, so force is minimum. And after this point, we are getting a positive slope, because after this double differentiation is negative. So that's why the slope is positive. That's the graph. Yes? Fine. So that's the main thing to understand here. Then any other doubts if you have asked? No doubts. Hmm. So let us solve some questions. I have some book, and from that book I will take some questions. Yeah, I think now only he's joining. Okay, I will add him. No, this is Darshan. Where is Abdul Haq? You share him the link now. Please share the link with him. If you have his mobile number now, you send him the class link. What about NCRT question? Did you solve NCRT problems? Hmm? NCRT also you should solve in Kaggle. I think this is Olympiad level questions. Okay, any questions you have? Anybody having any questions? Give me any question you have. Then not there, then I will take some questions. Okay. Let me take another book. Okay, so this seems to be a good book. Okay, let us take some basic questions. Okay, let's start some questions. If you have any questions, you can send in the group, and those who are already in the group, you can add your friends in the group. Okay, you can add. Yeah, in the WhatsApp group, you can add so that directly they can send any questions. Okay, let's take a question, simple question. A force is given like that. Force vector is 6 I cap plus 2 j cap minus 3 k cap. It is acting on a particle, produces displacement. Displacement vector is S vector 2 I cap minus 3 j cap plus x k cap. X is a variable. The work done is 0. They are saying that the work done by this force is 0. Find value of x. Quickly do it. Find x. Fast. You can do the calculation quickly. Anybody can solve this question fast. Answer is 2. So anyone else? Darshan? What one? 2. 2. Darshan, what is your answer? Force dot displacement, do it. Constant force it is. So 6 into 2, 12 minus 3 into 2, 6 minus 3x. So 3x becomes 6, x become 2. Correct. Done. Right. Okay, let us move next. So question number 2, a body is moving unidirectionally under the influence of a power. So a body is moving right in this direction, and the power is given as a constant power. It is going only in one direction. Then question is, if the body started from rest time 0, so time 0, its velocity is 0, initial velocity is 0, and its displacement in time t. So after traveling some, let us say body has traveled, now time is equal to t. So what is the displacement? Let us say position. What will be the position in terms of t? That is the question. First option is that this x is proportional to t power half. Second, x is proportional to t. Third, x is proportional to t power 3 by 2. Fourth, x is proportional to t square. Do it fast. Power is constant. Power is constant. Option 3. Anyone else? Let us take that. So power is constant. Power, power is constant. Hmm. So we can take power as force, dot product of force and velocity. Same direction it is going, so cos 0 degree 1, so dot product. This is constant. Force is mass into acceleration, and this is velocity. This is constant. So acceleration and velocity. Mass is also constant, so I'll take that. So anyway, that is going to be constant only. Some different constant, but it is a constant only. Then acceleration I can write as uh, acceleration I can write, is it acceleration constant? So if acceleration is not constant, I can write in general dv by dt, and this is anyway v. So v dv by dt is constant. So v dv is equal to, or it is proportional to dt, it will come. Then I will integrate it. So if I integrate this, then this will become v square by 2 initial velocity. Uh, Three option. Let us check that. So it is v square by 2, 0 to v. This is proportional to t only, 0 to t. This side. That means v square is proportional to t. Okay. Then uh, v will become proportional to root of t, and velocity can be written as dx by dt is proportional to root of t. So dx proportional to root t dt. Then further integrate. Okay. Yes, Abdul. Can you see this? Can you hear me, Abdul? Yes, Abdul, can you hear me? Okay. So we are discussing some questions. If you have any doubts, you can send, okay, doubts, or you can tell me. I will add you in the group also, WhatsApp group. So then you integrate this one. This will become x. This will be proportional to t power half. It is, so integration will become t half plus 1 by half plus 1. Right. So that will become t power 3 by 2. So x is, this is a constant anyway, so t power 3 by 2. That's the answer. X is proportional to t power. Correct? Yes. Okay. Let us go to the next question. Next question says that there is a force acting f of x. Force depends on x as minus kx plus ax square. A particle which is constrained to move along x-axis. So the particle is constrained to move along x-axis. It can only move along x-axis. So it is subjected to a force in the same direction. So So force is only acting along the x-axis. Let us say in this direction force is acting. So this force depends on position. This is the position from origin. Let us say this is origin. So from origin position is x, and this is force. Force depends on position. K and A are some constant here. K and A positive constant. So K is a positive constant. A is also a positive constant. They are constants. Constants. Then they are saying that the functional form of potential. They are asking which of the graph between potential energy and x is correct. So I will draw the graph. You have to choose which of the graph is correct. First graph, potential energy versus x is like this. Second graph, potential energy versus x. Third graph, potential energy versus x. Fourth graph, try this. Try this question, all of you. Any of your friends are there, you can share the link. They can join also. But I will recommend also that you can better register the course. Course fee is 1 rupees, and including the tax it is 11 rupees. 10 rupees is extra for the tax. Okay, so that is like that. Because advantage will be there, I will be creating some materials, links, and study materials, tests, so that you can easily write it to register there. Try this. Course is given. So from force we have to draw the potential graph. Previously we thought about force graph from potential graph. From potential graph, force graph we try to find out. But now force equation is given. From equation of force we have to get potential graph. Option B. How do we decide it? We can think in reverse way also, because force is 0 means du by dx is 0. That idea you can think about it. Force is 0 means du by dx is 0. So du by dx, where is du by dx is 0 means slope of this graph should be 0. Slope of this graph means maximum minimum should happen. So if you think here force is 0, can you find out how many roots will be there? Force 0 means how many roots will be there? Two roots will be there. Good. Because it's a quadratic equation and one of the root is 0, right? Because x can be taken comma, right? Yeah, one of that means at x is equal to 0, force is 0, that we can understand. X 0, force is 0. So at x is equal to 0, force is 0. So at x is equal to 0, there will be either maxima, minima, or neutral. Remember, constant slope can happen. So either maxima, minima, or constant slope. Constant means zero's value should be constant. So can you think about at 0? At 0 maximum minima, anywhere is happening at 0 maximum minima. Here it is not maximum minima, right? Because the graph slope is not 0 here. So this can be rejected. So there is a possibility here, and this is not possible. So out of B and D we have to think about it. Out of B and D we have to think about it. So where is 40? First let us make 40 and find out. Suppose if I say 40, so that means minus kx plus ax square is 0. So if I take x common here, it will become minus k plus ax, right? This is 0. So from here x is 0 is one root. Another root will be minus k plus ax is equal to 0. So x will be k by a. So there are two possible solutions for this. So at this slope has to be 0. So that means slope has to be 0. Slope has to be 0. Remember, slope has to be 0. X is equal to k by a will be some positive this side. Slope is 0. So here slope looks like to be 0 because the graph looks to be flat. Here also possibility looks like. So this is okay. But what about other conditions? There is a maxima happening here also. There is a maxima happening here also. These possibilities look like, but what about this? Something else we have to think about it, because two solutions are coming. Slope or 0 at two place. Hmm. Here is it slope 0? Is it slope 0 looking like slope 0? Let me check that the graph. Uh, no, they have not given like that. They didn't give like that. They have given that it is just a concave graph. They have not given minima. They have not given minima here because maximum minima will be clear, but this graph they have not given minima. They are saying it is just decreasing. So now how should we think? Something else we have to think. Something else means what? Double differentiation. Can we find double differentiation of potential energy? Right. So if this is F, so F is what? F is minus kx plus ax square. And F is what? F is minus du by dx, right? F is minus du by dx. Okay. So this is minus kx plus ax square. So from here du by dx you calculate. What will be du by dx? Minus you take that side. So du by dx becomes kx minus ax square. Now let us further do differentiation. Let us do differentiation. One time more you do differentiation. You can take also and integrate and find out the graph of that, but I'm trying to choose from options. So I'm not directly doing the solution. I will do double differentiation. So d square u by dx square. A comes out, x differentiation with x is 1, minus a comes out, x square differentiation is 2x, right? X square differentiation is 2x. So That means k minus 2ax, right? So d square u by dx square. Correct. This is what it is. Double differentiation will tell the shape of the graph. Correct. Double differentiation tells the shape of the graph. Now, wherever double differentiation is zero, there is shape changing. Correct. Remember, double differentiation zero means shape is changing, either concave to convex or convex to concave. So here, if you put double differentiation zero, you will get only one value of x because this is a linear equation. This is a linear equation. Correct. So that means there is only one point in this graph where sign has to change. Sign has to change only one time. It is either going from concave to convex or convex to concave. One point. Now, can you figure out where it is happening? Figure out. Figure out. So if I choose this graph, let us say, so this is it? If suppose this is minima, then this is concave, and somewhere it has become convex, one point, and it looks like here also it is changing. Is it changing or not? Looks like somewhere also here it may change concave to convex. So there looks to be 2 points, but there should be only one point where shape should change. So this graph can be rejected. What about this graph? This graph only one point because this side is only one shape. It is only convex shape. Here they have not changed the shape of the graph. Are you able to understand this? Yes. This is this is only one place concave and then convex. After that it is convex only. The shape is not changed. But here it is concave, then convex, then concave. So two times it will change, which is not possible. Only one time it should change. So this is the correct answer. Clear? Yes. Now there is another way. If I directly want to solve this, then du by dx I got from here. From this step, I will try to solve this question by taking du integration. I will bring du one side and then kx minus ax square times dx I will write, and then I will integrate both sides. Right? Let us integrate. So initial potential energy, we do not know what is initial potential energy. We do not know. Let us say initial potential energy is u1, and this is potential energy at a distance of x. Or if you want, you can just do integration without any limit. You can also do. You can do integration without limit, and we will add one constant of integration, that is called indefinite integration. So let us do integration without limit. So integration of du will become u here. This k comes out, x integration is x square by 2 minus a comes out, x square integration is x cube by 3 plus one constant of integration. Let us add. This is a what type of graph it is? First of all, this looks like a cubic equation, right? It looks like a cubic equation. Cubic equation means cubic equation means what? Not parabola. Parabola it is not. It is a cubic equation means this can have three solutions. A cubic equation can have three roots, right? Quadratic equation has two roots. Cubic equation has three roots. So it should have three roots, but it's not necessarily all the three roots has to be real, because real roots and imaginary roots also exist. Okay, so if a cubic equation is there, there are three possibilities that there are two possibilities. One is that all the roots are real. Another possibility is that uh, two one root real and two roots imaginary, because imaginary roots comes in pair. Do you remember that? Imaginary roots in maths you must have studied, because plus minus inside the root, imaginary roots can come in pairs. Okay, so if I think like this here, mm, if I think here in these two graphs, so I can have three values of x, x1, x2, x3, where potential energy will be zero. Potential energy zero means I can find out. Okay. So if potential energy zero means we can have three solutions, but if all the three are real, all the three are real means it should cut the x-axis at 3 points. So both these graphs are not cutting x-axis at 3 points. None of the graph is cutting x-axis at 3 points, right? This is cutting 2 points. This is 1 point. Anyway, these two are rejected. These are also not cutting the graph at this 3 points. So if you say that two imaginary roots are there, then I can take one thing, that we can take two roots as imaginary. Two roots are imaginary and one roots are real. So that means one time only it should cut the graph, and cutting the graph happens here in this graph. One time it is cutting, that is the real root, and this is not cutting, it is just touching. So this touching means that is not the root, right? So this is the only root at one place, other two roots are imaginary. This is not at all cutting the graph, so that is not possible. Three roots cannot be imaginary. So this is a mathematical, analysis. Using mathematical analysis also you can do that. Clear? Any doubt? If you have, please ask. Any questions? Any doubts? So done. Then next, let us move next question. Now this is another good question. So particle of mass 1 kg is there, okay? And this particle can move along x-axis, one-dimensional motion, and the potential energy is given as x power 4 by 4 minus x square by 3. Potential energy is in joule, SI unit. Total mechanical energy of the particle is 2 joule. They are saying that the mechanical energy of the particle is 2 joule. Okay. Then maximum speed is, they are asking what is the maximum speed of this body. Mechanical energy is like the total energy. There are no other forms of energy. So you can apply mechanical energy conservation. So there is only kinetic and mechanical energy. Try this question. Root 4.5. Square root 4.5. Any other answer? Yes. No, nobody can do. What about others? Try this. It's not very difficult question. It's a basic level question. Mechanical energy is constant. Mechanical energy is the sum of kinetic and potential energy. U is the potential energy. And mechanical energy is already given to. So kinetic energy plus potential energy is equal to 2. You want maximum kinetic energy because speed you want maximum. Yes, yes. What is the answer? 0.25 newtons. Okay. Let us try this. So we want kinetic energy because we want maximum speed means kinetic energy is maximum. So you want kinetic energy maximum. So let us take kinetic energy for this side. 2 minus u. Now substitute u. U is this one. Substitute x power 4 by 4 minus x square by 2. Correct? Minus minus will become plus. Okay. Open the bracket, it will become like this. Okay. Now you want kinetic energy maximum. So what is maxima minima? You know, you have studied maxima minima. So maxima minima means differentiation of kinetic energy should be zero. You know that, right? For maximum kinetic energy, for kinetic energy maximum, differentiate kinetic energy and differentiation of kinetic energy has to be zero. So do that differentiation. So this differentiation is 0. Differentiation of 2 is 0. This is 1 by 4. X4 differentiation is 4x cube plus 1 by 2 comes out. X square differentiation is 2x. So solve out. 4 4 cancel, 2 2 cancel. So from here x cube minus x is equal to 0. There are three roots. I think cubic equation is coming. So you can take x common. So it will become x square minus 1 equal to 0. So x is equal to 0 is one root. X square minus 1 is equal to 0. From here you will get x is equal to plus minus 1. Right? From this solution you will get x is equal to, what happened to this question? Yeah, I think it got deleted or what? I think that file got deleted. Hmm, okay, that file got deleted. I'm not sure what I was doing this. What was the question? That was potential energy was given. So potential energy was x4 by 4 minus x square by 2. So kinetic energy plus potential energy is equal to mechanical energy, that was 2. So kinetic energy plus potential energy. So kinetic energy becomes 2 times potential energy. So I have substituted this x power 4 minus plus x square by 2. They were asking maximum speed. For maximum speed, kinetic energy should be maximum. So differentiation of kinetic energy with respect to x should be 0. So we are trying to solve this. So differentiation 2 is anyway 0 minus 1 by 4. This becomes 4x cube plus 1 by 2. X square is 2x. This is 0. 2 2 cancel. This is cancel. X cube minus x is 0. X square minus 1 factors. X is 0 is one solution. X square minus 1 is 0. So x can give plus 1 or x can give minus 1. These are the total three solutions of this. Now we need to find maximum value, right? So you can substitute this value and check also where will be kinetic energy maximum, because you know the kinetic energy formula is this, right? You can choose to substitute and check where will be kinetic energy maximum. Substitute and check. So suppose if I substitute 0, then x is equal to 0, what happens? Kinetic energy will be 2 minus, this is 0 0, right? That means this is 2. If I substitute 1 or minus 1. I think this will not affect because they are even powers. Either I substitute plus 1 or minus 1, they will give same value. So you substitute plus 1 or you substitute minus 1, the value of kinetic energy will come same. 2 minus 1 by 4 plus 1 by 2. Check out how much it is. So 2 half 1 by 4. So that means it is 4 into 2, 8. 9 by 4. Yes. So out of this value, this is the maximum kinetic energy, right? 9 by 4 is maximum. Let us choose this maximum kinetic energy and calculate its speed now. So kinetic energy maximum we got already 9 by 4. Now substitute half mv square and calculate its speed. Mass was given, I think, in the question 1 kg. Mass was 1 kg. So 1 by 2 into 1 into v square is 9 by 4. So v square becomes this 2 get cancelled, 9 by 2. So v will become root under 9 by 2. 4.5 root under 4.5 looks to be correct answer. V is root under 4.5 meter per second. That's the maximum speed. Are you clear about this? Yes. That's the answer. That's the correct answer, and our options are given as v equal to 3 by root 2 because 9 root 9 3 will come out, so 3 by root 2, that is the answer. Clear? Yes, not very difficult. Maximum minimum concept. Okay. Then minimum. What minimum? No, no, no. Suppose if you want potential energy to be minimum. So minimum means maximum minima, you know now. Maximum minimum means there will be dy by dx 0. So differentiation of potential energy should be 0. For minima also it should be 0 on. But that is differentiation, potential energy should be 0. If you are trying to calculate by potential energy, then also you can do that. Yes. Why you want slope greater than 0? Slope equal to 0 is maximum minima. Why you want slope greater than 0? We don't want, we want maximum minima. For maximum minima condition is slope 0. Slope 0 only is the condition. Are you understanding this? Right? Slope 0, because at the maxima or minima, the slope is 0 at this point or this point. Double differentiation, why do you want to do? I think it came here. Why do you want to do double differentiation? Oh, you are saying you are saying you are asking that we should do to check whether maximum minima happens. We want to make sure because the slope is 0 at this point or this point. But how do you know which is maximum minima? That is what you are asking, right? So here suppose you have taken kinetic energy, that was 2 minus x4 by 4 plus x square by 2. So first of all, you have done differentiation of kinetic energy, which has come 4 into 4x cube divided by 4, which get cancelled, plus 2x by 2 that got cancelled. So this has become minus x cube plus x. Right? Now, but this can be, we have got already 3 roots, right? We have got x0 minus 1 plus 1, 3 roots. Now, how do you know whether maximum? What I did is I just substituted these values in the kinetic energy equation, and I could compare which is more, which is less. Right? Okay. I did not. Hmm, hmm. No, no. See, first you are doing by potential energy. That also you can do, but I am doing by kinetic energy. Okay. So kinetic energy I got. Now your question is, how do you know slope? Slope. So means how do you know whether maximum minima is there? There is two approach. One is double differentiation you calculate. Double differentiation will give the shape whether concave convex. Suppose you do double differentiation of this. Suppose I do double differentiation. Differentiation, double differentiation minus this becomes 3x square plus 1. Right? This double differentiation I got. Now if double differentiation is positive, then that will be minima. Double differentiation negative is convex, that will be maxima. Correct? Right? So first what you can do is you can now check. Now you can check by putting these values. Check. So if you want maxima, then these values when you put it should come positive. Sorry, negative. Suppose if I put 0, I am getting 1 plus 1. So that is minima condition. I put minus 1 or I put plus 1. So it is coming negative, right? Minus 3 plus 1 minus 2 negative. So that is why, that means if you can take the value 1 or minus 1, here you will get maxima. And if you take value of x as 0, 0, here you will get minima. Are you understanding that? Okay, so value of x you can take 1 or minus 1, you will get maxima, and if you take value of x 0, you will get minimum. What you are doing is, see what you are doing, I will tell that. You are doing kinetic energy as mechanical energy minus total minus potential energy, right? You are doing this. Kinetic energy is mechanical energy. Now you want kinetic energy maxima. So for that, mechanical energy is anyway constant only, constant. So you have to subtract it smaller. So you are taking this as minima. So what you are doing is you are trying to calculate potential energy minima. You want to find where is potential energy minimum. So that is what you are doing. So potential energy you are differentiating. So potential energy was x4 by 4 minus x square by 2. Now you are doing the same thing actually, because when you differentiate this, you are getting 4x cube by 4, 4 get cancelled, minus 2x by 2, 2 get cancelled. So you will get this. Again you will get the same roots. See, when you will equate du by dx, you will get the same three roots, 0, minus 1, plus 1. And then you will do double differentiation. Double differentiation will give you 3x square minus 1. Right? This is what. Now again after getting these three roots, you will try to substitute and check where this come. You want this minima, right? So for that you have to get this as positive. You should get double differentiation positive because you want minimum potential energy. So positive when it will come, check. Suppose if I put 0, then it will come negative. If I put minus 1 or plus 1, then only I will get positive, because 3 minus 1 will give 2. So that means at either minus 1 or plus 1, I will get potential energy minimum. Then I can substitute here and calculate potential energy, and then I will substitute potential energy here, and then I will calculate maximum kinetic energy. Are you understanding this? Huh. That is minus 2, that is plus 2, right? It will differ, na, because you want here minima. Here I want kinetic energy maximum. Correct? That's why it is opposite now. It is opposite. Hmm. Okay. Then what else? Hmm. Okay, one important concept, not concept, it is just a simple thing. Suppose this is power versus time graph and power versus x graph, right? So you know power is equal to dw by dt. So I can write power dt is dw, and we can integrate this. Integration of dw will give total work, net work done. Okay, and this integration, what is integration means? What is meaning of integration? Area. So the area under this power time graph will give the total work done, which can also be written as change of kinetic energy, right? Change of according to work energy theorem. So suppose if this graph is there and you take between two time interval t1, t2, if you calculate this area, this area will give you the total work done, net work done, or this may give you the change of kinetic energy. This is one concept, which is not a new concept because you know what is area and what is slope of a graph. Similarly, suppose this is power graph. Let us say power graph. What does this area gives? Let us try to calculate. So power is dw by dt. So I want to write in terms of x. So how to write this? Force into velocity. But I want to write in terms of dx. Suppose if I write this as force into dx, that is what then? Hmm, so force. I want to keep dx term. So force uh, velocity is dx. Okay, force I can write as mass into acceleration. Let us try. Okay, dx by dt I will write as velocity first. Dx by dt is velocity. Acceleration I will write as v dv by dx. Yes, I can write acceleration as v dv by dx. Now you see dx term is coming. This is power. So now you can see here that power dx term I will bring this side, and this will become m v into v square will become dv. Now you integrate. This is area under power x graph. This area in this area under power x graph. This area is different area. So this area will give, now this side you do integration. This mass comes out, integration of v square dx. V square dv. And suppose velocity changes from u to v, then integration of v square is v cube by 3, and velocity is going from u to v. So this area will give us m by 3 upper limit minus lower limit, v cube minus u cube. This is a very important concept. In some problems it can be done. Some problem means wherever they have given this area is power x graph. Remember px graph area. Px graph area between 2 points. This area if you calculate, this area will give this value m by 3 v cube minus u cube. Clear? Now solve one question on this. There is a question on this. Uh, Maybe in PYQs this question has come. This is power graph and this is x graph. The graph is like this. This value is 2 and this value is 4 and this value is here 10. X is in meter, power is in watt. Everything in SI unit it is. Now question is, mass of the body is given as 10 by 7 kg. The particle A of mass, this is moving in positive. So this particle is moving in positive x direction. Is moving. Okay, its initial position is 0. So initial position is this is x equal to 0, and initial velocity. So here initial velocity, that means u they have given. U is 1 meter per second. They have given initial velocity. Okay, and this power x graph is given. What is the velocity at 10? So when x is 10 meter, what is the velocity at x is equal to 10 meter? That is the question. They have given initial velocity. They are asking final velocity. Graph is between P and X. Try to use the area concept here. See? Any other answer? Anyone else? Abdul? Darshan? Any answer? Quick. This is not very difficult. You need to do this calculation. Do it fast. Area, calculate area. What is the area of this graph? So trapezium. This is parallel side. This is 2. This is 4. Right? This is 2. This is 4. So area is half into sum of parallel side 2 plus 4 into height. Height means this, which is 10. This is equal to m by 3. Mass is 10 by 7. 10 by 7 divided by 3. V cube minus u cube. Initial velocity 0 anyway. Solve it. Now it is very easy, right? This is 6 by 2, 3. 3 into 3, 9. 9 into 10 will come. Is 10 by 7. V cube. U cube is that is 0 anyway. So this 10 10 will go away. 9 into 7, 63 it is. V cube it is coming. V is coming cube root of 63. Cube root is possible or what? Nearly 4 it is possible, na? Yes, I think nearly 4 we can take. Correct, na? Nearly 4. If you take 64, 4 into 4 into 4. So approximately 64 we can take this 64 cube we can take. So that means approximately it will give us 4 meter per second. Clear? Yes, so you can work out questions on this. So done. So we'll wind up now. Anybody having any doubts, you can ask. I give you time to ask questions, doubts. Okay, then let us wind up today's session. We'll see then in the next class. Okay. Bye bye all.